Section 1.2 Algebraic Expressions. Objective: to simplify and evaluate expressions using the order of operations to solve the problems. A variable. A variable is a symbol, usually a letter, that represents one or more numbers. Typically, the letter N, X, Y, and Z are used to represent numbers in our equations and expressions. All letters can be used except for the letter O because that would look too much like a zero. Algebraic and variable expressions. An expression that contains one or more variables is an algebraic or a variable expression. An example, 3x is an algebraic expression. It contains a variable and a constant, which in this case is a coefficient. 3x minus 2y. Typically, there are more than one variable and also contain operations. 3x minus 4m over k. And also 3 times the quantity of x minus y, quantity squared. What we want to do is to evaluate an expression. To evaluate an expression, we substitute numbers in for the variables in the expression and then simplify the expression following the order of operations. Our order of operations is as follows. Step 1, we want to simplify grouping symbols. That would be brackets, braces, and parentheses. We want to evaluate what's inside of them until we get one number or constant or term inside. Number 2, we simplify exponents. Number 3, we multiply and divide in order from left to right. And number 4, we add and subtract in order from left to right. Let's look at the procedure to evaluate an expression. Step 1, we want to copy the problem from the book. 2, substitute the values of the variables into the expression. 3, simplify using order of operations. So here, we want to evaluate this expression for the given variables. So we're going to copy down 4y minus 3xy and then substitute these values. So 4 times y, which is 3, minus 3 times x, which is a negative 2, times y, which is 3. Then we simplify in order from left to right. 4 times 3 is 12, minus 3 times a negative 2 is a negative 6. A negative 6 times a negative 3 is a positive 18. Then we're going to add, since they're both positive, same sign combined, gives me a positive 30. Let's continue with some more examples. Number 1, negative 2y minus 3x plus y minus x, using x equals 2 and y equals a negative 3. We copy the problem, then we substitute 2 times a negative 3 minus 3 times 2 plus a negative 3, or you could just put minus 3, minus 2. Then we're going to take care of the multiplication first. Negative times a negative is positive 6. Negative times a positive is a minus 6. This is a negative 3 minus 2. 6 minus 6 is 0. 0 minus 3 is a negative 3. A negative 3 minus 2 is a negative 5. And notice we always work the problem down the page. Number 2, copy the problem. A negative 4 times a minus 2b plus a minus b. A is a negative 1, b is 4. Substituting, 4 times a is a negative 1 minus 2 times b, which is 4, plus a, which is a negative 1, minus b, which is 4. Again, we could have put minus 1 here. Simplify inside our parentheses, negative 4 times a negative 1 minus 8 plus a negative 1 minus 4. Again, simplify inside the parentheses, a negative 4 times a negative 1 minus 8 is a negative 9, minus 1 minus 4. Negative 4 times negative 9 is 36, minus 1 minus 4. And then now we just add or subtract depending on our signs. 36 minus 1 is 35. 35 minus 4, our answer is 31. Example 3, a squared minus b cubed. A is a negative 2, b is a negative 1. Substituting, a is a negative 2, so we have a negative 2, quantity squared, minus b. b is a negative 1, cubed. Simplify the exponents. A negative 2 times a negative 2, since it's squared, is a positive 4. Bring down the minus sign. A negative 1 times a negative 1 is a positive 1, but times a negative 1, since it's cubed, is going to give me a negative 1. This gives me 4 plus 1, and I simplify to 5. Number 4, 3 times the quantity of m minus n quantity squared. M is 5, minus n, which is 3, squared. Here we have an exponent, but I also have a grouping symbol. I have to take care of the grouping symbol first. 3 times 5 minus 3, which is 2, squared. Now I have an exponent, so I have to take care of my exponent before I can multiply. 3 times 2 squared, which is 4. And finally simplify 3 times 4 to 12. Number 5, 3 times the quantity of n minus m minus the quantity of m minus n, all over a negative 2n plus 5. Substituting, 3 times n, which is 3, minus m, which is 5, minus m, which is 5, minus n, which is 3, over a negative 2 times n, which is 3, plus 5. Here we can work on the top and bottom of the division symbol. I'll simplify inside the parentheses. That gives me 3 times 3 minus 5 is a negative 2, minus 5 minus 3 is going to give me a positive 2, over a negative 2 times 3 is going to give me a negative 6 plus 5. On the top, we simplify the multiplication, which is going to give me a negative 6 minus 2 over a negative 1. Simplify the top, which is going to give me a negative 8 over a negative 1, and that simplifies to a positive 8. Number 6 brings in absolute values. 2 times the quantity of the absolute value of 2x minus 1, 3 times the quantity of the absolute value of 3 minus y. X is a negative 2, y is 3. Substituting, 2 times the absolute value of 2 times a negative 2, minus 1, minus 3 times the absolute value of 3 minus y, which is 3. Simplify inside our absolute values because they are grouping symbols also. They also perform an operation. 2 times the absolute value of a negative 4 minus 1 minus 3 times 3 minus 3 is 0. 2 times the absolute value, again simplifying inside the absolute values, gives me a negative 5, minus 3, the absolute value of 0 is 0, and remember we're multiplying. This is going to give me 2 times the absolute value of a negative 5 is 5. 3 times 0 is 0. We actually don't need to write that, but I did. 2 times 5 is 10. 10 minus 0 is just 10. Number 7, x squared minus y squared, where x is the square root of 3, y is the square root of 5. Substituting, x is the square root of 3, quantity squared, minus y, which is the square root of 5, quantity squared. Here, the square root of 3 times the square root of 3 minus the square root of 5 times the square root of 5. That gives me the square root of 9 minus the square root of 25. The square root of 9 is 3, minus the square root of 25 is 5. Our solution is a negative 2. Let's look at another example. The expression negative 0.06y squared plus 3y models the percent increase of Latin voters in a town from 2008 to 2010. Find the percent of increase of Latin voters by 2008. That is an 8-year increase from 2000. Therefore, we're going to let y equal 8. Therefore, we substitute negative 0.068 squared plus 3 times 8. The simplest thing to do is plug this into a calculator, and when you do, your percent increase is going to be 20.16%. In expressions, we have terms. A term is a number, a variable, or the product of a number and one or more variables. So an example would be 4y. That is one term. Also, we have expressions that could be 3 minus 3m. Here we have two terms. 3 is one, and the term 3m is the second term. Or we could have 4x squared minus 3x plus 1. Here we have three separate terms. Some are algebraic, some can just be a constant. It's in front of the variable. So here I have 4x squared minus 3x plus 1. We have three separate terms. The number in front of the variable is known as the coefficient. So here, my coefficient is 4. Here, my coefficient is a -3. This is just a constant. Procedure to combine like terms. Number 1, copy the expression. 2, simplify by using distributive property. And 3, we want to combine like terms. Remember, combining like terms is when we add and subtract terms that have the exact same variables and the exact same exponents on those variables. Number 1, simplify by combining like terms. Here I have 1, 2, 3, 4 terms. My like terms are all the terms that have k's in them. Notice the exponents are the same. Here, when I have like terms, all I'm going to do is add or subtract the coefficients, keeping the variables the same. A -4 minus 8 is a -12k. A -12 plus 7 is a -5k minus 3. And then we bring down any unlike terms. Number 2, the first thing we want to do is copy the problem. Then we're going to simplify by using the distributive property. A -2 times 3z is a -6z. A -2 times a +4 is a -8. This is just like a -1 out in front of the parentheses. So here I'm going to use the distributive property again, which is a -4z plus 3. Now I want to combine like terms. My two like terms are the z's and also the constants. So here, a -6z, and then we use the symbol that is in front of the other term. So a -6z minus 4z is a -10z, and then a -8 plus 3, which is a -5. Number 3, again, copy the problem. Here we have common terms, and our like terms are going to be the x squares, and also the x's are like terms. So 1/3 x squared minus 2/3 x squared. 1/3 minus 2/3 is a -1/3 x squared. Then we have a +1/2 x, and we also have another +1/2 x. And 1/2 plus 1/2 is just 1 x. We could put the constant 1 for the coefficient, but that's already known to be there. Number 4, we distribute. A -3y times 4 is a -12y. A negative times a negative is a +3xy, and we put our variables in alphabetical order. A -x, a negative times a positive is a -3, again, alphabetical order, xy. And a negative times a negative is a +3x. Our like terms are just the xy's. So I'm going to combine those. 3xy minus 3xy is 0, so they cancel out. We don't put 0xy because 0 times anything would just give us 0. So we're left with a -12y plus 3x. You could also write that as 3x minus 12y, and that, we recall, is the commutative property, and we still know that they are equal. Number 5, a -6a minus 3 times the quantity of 4b minus 2a. Here we'll distribute. That gives me a -12b. A negative times a -2 is a +6a. My like terms are my first term, which is an a, and my last term, which is an a. Combining, a negative plus 6 is a 0a. Therefore, that cancels out, and I'm left with a -12b. Our last example wants us to find the perimeter of this figure, but then simplify the answer. Recall, the perimeter of an object is the sum of the lengths of its sides. In other words, we want to add up the lengths of each side. So let's start with this side, which is C, and then go counterclockwise around the circle. C plus C over 2 plus D plus D minus C plus D plus C over 2 plus C plus D, and that takes us back to the beginning. Now what we want to do is combine like terms in this expression. So all our C's need to either add or subtract depending on the sign of the coefficient. C plus 1/2 C is 1.5 C. 1.5 C minus 1 is just a positive half C. A positive half C plus a positive half C is 1C. 1C plus 1C is 2C. And I've used all those terms. What remains are my other like terms, which are my D's. D plus D is 2D, plus D is 3D, plus D is 4D. So my solution for the perimeter is 2C plus 4D.